Circles. To begin with circles, we need to define some basic vocabulary. The first thing is, if you see a circle with center E, the symbol for that would be a little circle, and that would have a C next to it. And so that would mean this is a circle with center C. If it was another letter in the center, it would be circle with that other letter. R, we always know what R means. R is always the radius. So now we'll go down below and fill in these things. Chord. A chord is a line segment whose endpoints are on the circle. So a chord, this I made a little bit too big, but the endpoint should be right on the circle. So a chord is a line segment whose endpoints are on the circle. Are on the circle. So this would be one end of this line segment, and this would be on the other end. A diameter is a chord that goes through the center. So if this is the center of my circle, a diameter would start at one endpoint on the circle and go through, and that would be a diameter. Secant. A secant is a line or ray that contains a chord. A line or ray that contains a chord. So if I were to make something like this and add lines, arrows on either side, this line right here would be a secant because it contains a chord. Let's do another one. Let's do a ray. So here would be a ray secant, but it's still called a secant. So if I started here and I made the arrow here, this would be a ray because it starts at one point and goes infinitely in the other direction. This would be a ray, but that contains a chord. It would also be a secant. Both of these are just called secants. Tangent. Tangent is a line that intersects a chord at exactly one point. It doesn't have to be a line, it could be a line segment. But basically, when it's tangent, it intersects a circle. Oops. Intersects a circle at exactly one point. Okay, so if we can draw a line, it would just touch just at one point like that, and there would be only one place it would touch. And so this would be an example of a tangent. It doesn't have to be exactly vertical though. Okay? Okay, note, tangent is also an adjective. Okay, so tangent can also be can be used as an adjective. So if you have externally tangent, if you have two tangent circles that are externally tangent, that means the external sides touch at exactly one point. So that would be externally tangent. Internally tangent would mean they would touch at one point and one circle would be inside the other. Internally tangent. So here's a circle, and then the other circle and they would only touch right here at one point. Theorem number 1. If you have a tangent to a circle and draw a radius that touches the tangent, then... Alright, well let's draw it and see what it looks like. So we draw a tangent. It's going to touch touch at one point. And draw a radius that touches the tangent. So we start at the center and go out. It turns out that the radius and the tangent will be perpendicular. Perpendicular. Here's a 90-degree mark right here. Pick any point outside the circle and draw all lines through that point that are tangent to the circle. Okay, so let's pick a point here. Let's call this point P. And let's draw some tangent. So that would mean it would reach here. It touch exactly once. And then we could do another one that would be here, and it would touch exactly once. If you look at those two lines or line segments, those are congruent. The tangent segments between the point and the circle are congruent. Between the point and the circles are congruent. What does that mean? That would mean the distance from here to here would be the same as the distance from here to here. So if this is point A and this is point B, it would mean that AP is equal to PB. Oops, this is supposed to be AP, the distance of line segment AP is equal to the measure of BP. Okay. A circle is inscribed in a polygon if it is tangent on each side, which means it touches exactly once. So here would be a place of tangency, 1 point, 1 point, and 1 point. To the right of the circle is inscribed, the circle is inscribed in a polygon, find measure of x. Okay, so they give you that this whole distance is 20. They give you that this whole distance is 25. Well, and they're tangent. So if this is 7 from here to here, this has to be 7 from here to here, right? Because these are tangent and they meet at one point, and these two are congruent. If this is 7, this whole distance is 25, this has to be left over at 18. And again, this one and this one are congruent, so this also has to be 18. Thus, the answer here is x equals to 2. X equals 2. Turning the page. I'm going back because this is the end of the notes section, but what I'd like you to do is I want you to do the first page complete. The first page of actually the next page, which is complete the first page. It's 9.1 and 9.2 classwork, but it's double-sided. So I just want you to do the front side. So I want you to just complete the first page, which is actually the next page in your packet, which is 9.1 and 9.2 classwork. Again, only the first page. And I'll see you next class.